Hello learners, welcome to our fifth lesson. We are still looking at Form 2 Chemistry. That is the first topic. I'm your teacher, Teacher Anis. So the first topic in Form 2 is the structure of the atom and the periodic table. So today we are looking at the last part of this topic. That is, we shall be looking at two things. One, the chemical formulae, and two, the chemical equations. So we start by looking at the chemical formulae. What is chemical formulae? So chemical formulae, this is the representation of a chemical substance using chemical symbols. We have seen these chemical symbols as we were looking at the periodic table. So we saw that every element is represented by its own symbol. For example, for hydrogen, the chemical symbol is H, for calcium, Ca, and so on. So chemical formulae shows the constituents of elements and the proportions in which they are combined. When atoms combine, they form compounds. For example, if we have sodium atom and sodium and chlorine reacting, and they will form a compound known as sodium chloride. So during this reaction, sodium will lose an electron, as we saw that sodium loses an electron to form a positive ion, or in other words, a cation. Then chlorine will gain an electron. So we saw that chlorine gains an electron to form a negative ion, or rather an anion. So during this reaction, sodium will lose an electron to form sodium ion. Then chlorine gains an electron to form chloride ion. These two ions will combine to form a compound known as sodium chloride. So this is the reaction between the sodium ion and chlorine ion. They combine to form sodium chloride. So these are the symbols of sodium ion and chloride ion. Then this is sodium chloride. That is an example of an equation. So in order to write the correct chemical formulae, it is necessary first to know the symbols and the valences of the elements that are being involved to form the compound. So after you know the symbols and the valences, now it will be easier for you to write the chemical formulae. So for example, if you want to write the compound of magnesium fluoride, this is our example 1. The chemical symbol for magnesium is capital M and small g. Its valence is 2, so we write it up there. Then we have that of fluorine. Fluorine, its chemical symbol is F. So F, its valence is 1, as indicated up there. So we have an NB here. If we have a common factor, so we first check for a common factor in the valences. If there's a common factor, we first simplify. So if there's no common factor, we just interchange the valences. But if there's a common factor, we simplify by dividing by the common factor. So for magnesium and fluorine, there's valence 2 and valence 1. So here we don't have a common factor. So we are going just to interchange these valences. So what is the valence of magnesium is 2. We'll go down to where fluorine is. And that of fluorine, which is 1, will come where magnesium is. So that is why we are indicating this cross here, or using these lines here. They are indicating the interchanging of these valences. So now these two will go to fluorine, 1 will go to magnesium. So we don't write 1. So now the chemical formula will be magnesium fluoride. Capital M, small g, capital F, and 2 at the end there, or below fluorine. Let us look at calcium oxide. So the chemical symbol for calcium is capital C and small a. So we have the valency of calcium is 2. Then that of oxygen, the chemical symbol is O, and its valency is 2. So do we have a common factor? Yes, 2 is a common factor. So we simplify by cancelling the 2. So 2 will simplify that of calcium and that of oxygen. So we shall have one here and one here. So after we interchange, so calcium will have 1 and oxygen will have 1. We have said that we don't indicate 1. So it's just to show that the calcium atom is 1 and the atom, we only have only 1 atom of oxygen. So that is the chemical formula for calcium oxide. Here we have aluminium 3 oxide. So the valence of aluminium is 3, that of oxygen is 2. So do we have a common factor here? No. 3 and 2, we don't have a common factor, so we cannot simplify this one. So the only thing we need to do is to interchange these valences. So these 3 will go to oxygen and these 2 will go to aluminium. So there will the compound will be aluminium 3 oxide, and this is how it is written. We have capital A, small l, the 2 there, then oxygen, and then the 3 that came from aluminium. Let us look, for example, another compound, that is potassium carbonate. So potassium, we have 3 atoms of potassium element, and we have 1 atom of potassium, and then we have that of carbonate. So if we want to write this compound, we are going to write the symbol of potassium, that is K, and that of carbonate, that is CO, and 3 down there. The valence of potassium is 1, and here we have carbonate, it is a radical. We have its valence is 2. So we are going to interchange these valences here. Because there's no common factor, we have 1 and we have 2, so we just interchange. So 2 will go to potassium and 1 will go to carbonate. So now the compound become K2CO3. So that is potassium carbonate. And finally we have this other example here of calcium nitrate. So this is how we write the formula for calcium nitrate. So calcium has a valency of 2, and nitrate, we saw it has a valency of what? Of 1. So there's no common factor. We have 2 and 1, so we only interchange. So 1 will go to calcium and 2 will go to nitrate. Because now we have a 3 down here, we must introduce these brackets. So now the formula becomes Ca into brackets, the nitrate, and then at the end here we have 2. So that is how we write the chemical formula for calcium nitrate. Okay, now let us look at the chemical equations. What is a chemical equation? A chemical equation represents a chemical change by use of symbols and formulas. So the formulae of the reactants are written on the left-hand side. Those are the reactants, and those of the products are written on the right-hand side. So we first start by writing the reactants, and then there's an arrow. On the right side, we write the products. To write the correct chemical equations, one must write the correct formulas of the reactants and the products. So you must know how to write the chemical formula of the products and that of the reactants before you write a chemical equation. So it is very necessary that you should know how to write this chemical formula. So for example, if we want to write a chemical equation for magnesium oxide, so we see that magnesium is reacting with oxygen to give us magnesium oxide. Magnesium and oxygen, these are the reactants. Then you can see there's an arrow here. Then on the right hand side, we have the product. The product is magnesium oxide. This reaction is not balanced, and we are going to see how we balance chemical equations and what is balancing. So this is how we write the chemical formula, the chemical equations. So what we have to, for us to write chemical equations, for us to write the correct chemical equations, we must balance. The chemical equations must be balanced. So what is balancing chemical equations? So balancing chemical equations is the process of making the number of each kind of atom on both sides of the equation to be equal. So if we have one atom on the reactant side, it means even on the product side, the number of atoms will be 1. So the number of each kind of atom on the reactant side must be equal to the number of atoms of the same kind of atom on the product side. A chemical equation is correct if it is balanced. So an equation is balanced when the number of atoms of each type of the reactant is equal to that of the product side. This is because atoms are neither created nor destroyed during a chemical reaction. So we don't form or we don't create atoms or we don't destroy atoms when we are reacting or when we are doing a chemical reaction. So these are below are the guidelines that should be observed when balancing a chemical equation. So we are going to see how we balance chemical equations. So the first step here is you write the chemical reaction in words. For example, here I have used an example of the reaction between copper and oxygen. So this is the word equation. We saw how to write word equations in form 1, so that is not a big task. So copper plus oxygen, then we have this arrow here to form copper 2 oxide. So our reactants are copper and oxygen. So they are forming a product known as copper 2 oxide. So the first step, we write this reaction in words. Step number 2, we write the correct formulae for both the reactants and the products. So where we have copper, we know the formula, the chemical symbol of copper is Cu, that of oxygen is O, and it is forming a product known as copper 2 oxide. So this is how copper 2 oxide is written, but then this reaction, remember, it is not balanced. You can see we have 2 oxygen atoms on this side and 1 on this side. So step number 3, check whether the number of atoms of each element on the reactant side is equal to that one on the product side. So in our equation, we have seen that the number of oxygen atoms on the reactant side are 2, but on the product side we have 1 atom. So that means the equation is not balanced. If the number is not equal, then we multiply the chemical formulae containing the unbalanced atoms with the lowest multiple. So we use the smallest number. We start by multiplying by the smallest number. So the smallest number that can balance this oxygen here is 2. So on the product side, we multiply by 2 to make this number of oxygen atoms to be 2. So now we shall have 2 atoms of oxygen and 2 of oxygen in the reactant side and in the product side. Then what has happened to the number of atoms in the product side of copper atoms? Now the copper atoms has become 2. So this makes the reactant side to have 1 copper atom. So we are going again now to multiply by 2. So we shall have 2 copper atoms in the reactant side and 2 in the product side. Again, we have 2 atoms of oxygen in the reactant side and 2 of the oxygen atoms in the product side. So step number 4, we check again to ensure that all the atoms are balanced. So we go back to check whether they are balanced. We have seen in our equation they are balanced. We have confirmed. Then step number 5, a chemical equation is complete if the physical states of the reactants and products is indicated. So which are these physical states? These are solid, gases, liquids, or if it is in solution or in aqueous form, we use the symbol AQ to show that they are in aqueous state. So in our equation here, copper, we are reacting copper metal with oxygen gas. So copper is a solid, copper metal is a solid, so it is represented by the state symbol S. Oxygen is a gas, so that's why we are having G there. Then copper oxide is a solid, so we have S there. So those are the 5 steps on how we balance a chemical equation. So you have to begin in each one of them if you want to learn how to balance a chemical equation. So here we have some 2 questions on what we have learned. So for example, we are told here, we write the chemical formulae for the following compounds. We have calcium fluoride, carbon 2 oxide, carbon 4 oxide, lead 4 oxide, aluminium carbonate. So we have seen how we have written these chemical formulae. So let's look at maybe 3. We'll first look at that of calcium fluoride. So we said we begin by writing the chemical symbols. That of calcium is Ca. Then the valency of calcium is 2. Then we have fluorine, its symbol is F, and its valency is what? Is 1. So do we have a common factor? No, 2 and 1 is not common. So we just interchange the valency. So we shall have calcium. This one in fluorine will come to calcium, so we don't indicate 1. Then we have fluorine and we have 2 there. So that is the chemical formula of calcium fluoride. Let us look at carbon 2 oxide. So we have carbon, its valency is 2 in carbon 2. Then we have that of oxygen. Oxygen is O, its valency is 2. So if we have a common factor here is 2, so we can cancel these 2 with this one. So this will be 1 and this one will also be 1. So for carbon 2, it is written as CO. CO. What about aluminium carbonate? So let us write the symbol of aluminium. So the chemical symbol of aluminium is capital A and small l. That of carbonate, it's a radical. We have C, we have O, then we have 3 here. The valency for aluminium is 3. The valency of carbonate is 2. So we don't have a common factor here. So the only thing we need to do is interchange the valences. So aluminium now will have 2. So we have aluminium This is small l, not capital. So aluminium will have 2, that is from the carbonate. Then the carbonate, because of these 3 here, we introduce a bracket. So this will be CO3, and then we have these 3 from the aluminium will be outside the brackets there. So that is the chemical formula for aluminium carbonate. It is very easy to write the chemical formulas of compounds. So we only need to know the symbols and the valences. Then if we have a common factor, we simplify and we interchange those valences. Our second question, we are completing the word equations, then we balance. So we have sodium hydroxide and dilute hydrochloric acid. So here we have sodium hydroxide. Sodium hydroxide is NaOH, that is sodium hydroxide. So we have N, small a, O, and H. The symbol of sodium hydroxide is solid, plus we have dilute hydrochloric acid. This is HCl. So this is aqueous. It is in solution. It is dilute. Then we have our arrow here to indicate the other side of the product. So this one will form sodium chloride plus water. So we have sodium chloride plus water. Sodium chloride plus water. So sodium chloride is aqueous. So we have aqueous here, and then water is in liquid form. So let us look whether our equation is balanced. So we have one sodium atom on the product on the reactant side and one on the reactant side. So sodium is okay. We have one oxygen here, one oxygen here. It is balanced. We have this hydrogen, so 2 hydrogen atoms and 2 hydrogen atoms in the product side. It is balanced. One chlorine atom and one chlorine atom on the product side, meaning the reaction is balanced. Let us look at another example. For example, we can use sodium. We don't have sodium metal here, but we have zinc oxide plus dilute sulfuric acid. So we have zinc oxide. So this is the word equation, zinc oxide plus dilute sulfuric acid. This will form zinc oxide plus water. So we have zinc oxide. So zinc is ZnO. So zinc, Z small n and O, zinc oxide. This is solid, that is solid, and we are reacting this zinc oxide with dilute sulfuric acid, so plus dilute sulfuric acid. So this will be aqueous, is in solution. This is capital S, capital O. Let me write that correctly. So we have H2 SO4. So this one is forming zinc sulfate plus water. Water is in liquid form. Zinc sulfate is a solution. So this is water. It is in liquid state. Zinc sulfate is in solution, so aqueous. And sulfuric 6 acid is also in solution. It is dilute, so aqueous. So let us now look whether this equation here is balanced. So we have one zinc atom here. We have on the reactant side, and we have one zinc atom in the product side. Zinc is okay. We have one oxygen here and 4. So that makes the oxygen to be 5. So 1 plus 4, 5. That is the reactant side. In the product side, we have 4 oxygen atoms plus 1. That is in water. So 4 plus 1 makes that 5, meaning oxygen atoms are 5, 5, meaning it is balanced. Then we have hydrogen. We have 2 hydrogen atoms on the reactant side, 2 on the product side, meaning hydrogen is okay. Then for sulfur, we have 1 sulfur atom here and 1 sulfur on the product side, meaning that sulfur is also balanced. So that reaction is correct. It is the symbols are okay and the balancing is correct. So that is the correct equation for the reaction between for the reaction between zinc oxide and sulfuric 6 acid. And that is how we write balanced chemical equations. So make sure you write the rest for you to continue learning on how to write balanced chemical equation. So that marks the end of our lesson 5 and also the end of the chapter 1 of the Form 2 work or the Form 2 chemistry. So in our next lesson, again, we are going to look at the second topic, that is the chemical families. So let us meet in our next lesson. Thank you for listening.